Newton's first law of motion, or the first law of motion. In previous video in kinematics only inform you about position, velocity, motion path, and etc. but not explaining the cause of the motion, why its move is unclear and how its move is unclear too. So by that problem, we need an answer, which is law of motion now answering or give us answer about the cause of motion, or in the future we call it as dynamic. So in the future, if you find like electrodynamics, it means that the phenomenology of motion because of electro or magnetic field, and so on for fluid dynamics, which is explaining about how the cause of fluid itself. For now, we will discussing about the first law of motion, which is related to F factor or force factor is equals to zero factor, which means that in this condition, mass is conserved quantity. And then by these conditions too, acceleration factor will equals to zero. That means that the object in physical system will rest or moving constantly at straight line. The rest, it means that has velocity as zero factor, so it satisfies the acceleration factor is zero, or moving constantly, which is the velocity factor is a constant, which is satisfying the acceleration factor is equals to zero factor. But why is about straight line in space? First of all, let R is a vector which is defined as x1 multiplied by e1 plus x2 multiplied by e2 and so on until xn multiplied by en, which is this n is about index, not power. So I denote this summation as sigma like this, which is our vector is about position vector for object in our physical system, which our physical system is in n-dimensional vector space. And notice that this EI vector is a basis, which is this basis may not orthogonal or normalize, or it just builds space or vector space as minimum span. So that means if I take the second derivative of position vector, I will get the acceleration vector equals to this long term, which is proof this form is for the audience. And by this form, we will get interesting properties of these results. First, we know that we choose non-trivial basis, which is all basis is a non-zero factor. And then if we choose that the second derivative of each component of factor is zero, that means we will have first derivative of each component is a constant with respect to time. The next one, if we choose the first derivative is equals to zero, that means component of position vector is a constant with respect to time, or just simply that the object in our system is in rest condition. And the next part is if we take the first derivative of the basis is a zero factor, we will get the constant direction of position vector. So that means we will have a basis that not change the direction along the motion. Next, if we take each component is zero, that means object in our physical system is resting but at origin point. And the last one, if we take the second derivative of basis is equals to zero, then we will have simply that the first derivative is a constant with respect to time. So the basis is changing but in constant with respect to time. By this condition, we will see that if this rate of change of basis is equals to zero factor, then it will return to condition when the first derivative is equals to zero. That means this condition is a special condition for the last condition. And now, what if the acceleration factor is equals to zero factor? Now I will divide the case of acceleration is equal to zero factor as two conditions. The first condition is at rest, which is each component of position vector is independent to time. So that means if derivative operate to xi, it will result to 0. And the next is that the rate of change of basis is a constant vector which is time independent, and as illustration, let our object at point A B like this and have direction of motion just like this at t is equal to t0. And after a few time, which is now is t equal to t1, our object still in A, B point, but with different direction, which satisfy the first law. The next condition is moving. For now, if our object is moving, then each first derivative of component need to be a constant, and the rate of change of basis need to be zero vector. Of course, for higher order derivatives with respect to t will give us 0, 2 in this condition. That means our basis is a constant vector with respect to time or time independent, and we choose that for non-trivial basis. Of course that in this condition, the first derivative of each component may 0, and in the beginning, we choose our basis is a non-trivial, which is non-zero vector. And of course, for condition before us rest object, which may be at 0, 0 point or origin point, the first derivative of our basis is a zero vector. It creates a special case as same as moving condition. In moving condition, we will get the motion path. We don't care about Cartesian, polar, and many other coordinate system, but this create a straight line for every coordinate system. To give you some illustration, we recall that M object as before, which has velocity vector as v1 at time t is equals to t0 at point in space as ab. Now, if we travel to t1 time or the time after t0, we will get the coordinate position is just like this, and the velocity is still the same, no direction change, and no velocity magnitude change. So we can just get the new coordinate as like this. So that means we can infer that first law of motion, which is force vector is equal to zero vector, has consequence as acceleration vector is equals to zero vector, which means that velocity vector will create a time independent vector. M is a constant with respect to time, and this will create a motion path as straight line for every coordinate system. That's how the first law of motion tell you about motion. I think that's it. Don't forget to share and subscribe, and see you later.